maybe today is a good day to ask a question or find questions on it. I'll ask at the end. I'm going to give you a few questions I think you'll get wrong. Just you, Lucas. Yeah.
So this is the only topic I fully reviewed, you know.
Oh, okay. Well, sweet. This is the first one. All right. So first thing, different types of numbers. You should know what an integer is, positive and negative whole numbers. You should be able to obviously put numbers on a number line, and you should be familiar with square numbers. What are square numbers?
Like 2 times 2.
Yeah, 1, 4, 9, 16, 25. So 2 times 2, 3 times 3, 4 times 4. Cubic numbers or cube numbers. 1, 8, 27, 64, and 125. Triangular numbers? No? They form a triangle, yeah. Probably more likely to come up in like a paper. 6. So 1, 3, 6, 10, and just continue to draw these shapes. Triangular numbers. They make a triangle. Okay, that's what triangle numbers are. Of course, we know how to get a highest common factor and lowest common multiple. To get highest common factor, there's a few different methods. I think the one we did was the prime factor tree method. If you need a refresher on that, you can ask. And you can also use the prime factor tree method to get the lowest common multiple. You need to know the difference between a prime and a composite number, or what prime numbers are. Maybe the first few prime numbers are always useful to know. The first prime number, of course, is
1.
very good, 2. 2 is the first. It has to have definition 2 factors. So 2, 3, 5, 7, then 11, and so on. They are prime numbers. Composite numbers, then anything with more than 2 factors. Rational and irrational numbers. So the definition of a rational number. What's the definition? Well, it's probably written there, but it can be written as a fraction. Anything that can be written as a fraction is a rational number. So you can convert it to a fraction. Irrational numbers then are numbers that cannot be written as a fraction. The most few obvious examples are like pi, or the square root of 2, or square root of 3, or square root of 6.
Can you technically do pi? Because isn't pi just like the radius over the circumference or something? Or the circumference?
Pi is a ratio, yeah, of the circumference of a circle to its diameter, but it doesn't give a whole number, and it does not. You think it would, and that's the whole reason why it's kind of special, but it doesn't. Okay. So you may be asked to just pick out an irrational number from a list of numbers. Which one is the irrational? That comes up quite often. Look out for square roots. Look out for pi and stuff like that. That's all that really can come up for you guys. You need to be able to switch between fractions and add and subtract and divide and multiply fractions quite easily. You only need a common denominator if you're adding and subtracting, of course, fractions. You need to work a lot with percentages, talking about percentage increase and decrease. Remember, if you were increasing something, you want to increase something by 10%, you can use a multiplier. So if you want to increase $60 by 10%, I would use the multiplier 1.1. So that refers to 110%. If I want to decrease 60 by 10%, I would multiply by 0.9. So that is 90% of its original value. Sometimes they ask you to work backwards. Try and think about what they would have multiplied by to get it in the first place. If you want to work backwards, then divide by whatever you think they multiplied by to find some sort of original price of something. So let's say something was decreased in price. Its price is now $25, and it was decreased 5%. How would I figure out what the original price was? Yeah, so don't get 5% of this. Think about, all right, it was some number, as you have, some number multiplied by 0.95. That was the original, so how do I work backwards in maths? If it was multiplication, divide. The opposite is divide, yes. So that number is, 25 divided by 0.95 will give you back to that number. Sometimes that can catch you out. Also, I think it might be on the next slide, but depreciation, multiple years depreciation. So if something's depreciating 5% every year, that would be the amount multiplied by 0.95, so that's 95% to the power, yeah, of the number of years, yeah. It's compound interest, yeah. Yeah. I think it's on the next page anyway. Simple interest, remember, only gives you the interest, the formula for simple interest, which is your principal times interest times years. So at the end of it, add on the interest and look out for it. That's a very common mistake, especially in paper 2, where or in paper 4, I mean, where you don't add, they ask you, oh, what is the total amount? Or in a compound interest question, they ask you just for the interest, where you have to subtract the principal afterwards. Just watch out for those. And then surds, we need to be able to rationalize the denominator. So if we have a surd, such as 6 minus root 2 over 5 plus root 3, how would I rationalize this denominator? 5 minus root 3, 5 minus root 3. Very good. So we rationalize. Rationalize the denominator is turning the denominator into a rational number, or so we don't have a surd anymore, irrational number in that denominator. Don't want irrational numbers there, okay? And what else? The rules of exponents and laws of indices. Some of the ones that we're not maybe wonderful at is when we have a negative, or if there's a fraction involved. So if I have something like x to the power of negative 3 over 2, that can be rewritten as 1 over x to the 3 over 2. And the 3 over 2 can be rewritten as? It's the cube root of x squared, yes. The square root of x cubed. Oops. The square root of x cubed, yeah. So this half is square root, and the power 1/3 is a cube root. They can prove quite tricky sometimes. Remember, a power to a power as well. If I have 2 to the power of 3 to the power of 4, that's 2 to the power of 12, not 7. Because 2 to the power of 3 times 2 to the power of 4, that's 2 to the power of 7. Yeah. Okay. Standard form is something that perhaps we didn't spend a lot of time on because it's not maybe the hardest thing in the world, but standard form, remember you can use these rules of indices. So if I have a multiplication problem, 6 times 10 to the 7 times 0.4 times 10 to the 6. I'm going to use something that gives a whole number, 1.2. Yeah, or not a whole number, double-digit number. No, wouldn't be like that. Jeez, that's terrible. 9.2. Okay, so how would I do this? I'm just trying to make it more difficult. Okay, so I would multiply the 6 by the 9.2, yeah? And I know it's 10 to the power of 13 by adding up the powers here. So maybe do a rough work here. 9.2 times 6, we all know what that is, of course. 55.2. Well, 9 times 6 is 54, and 9 times 2 is 12, but it's 1.2. So 55.2 is correct. 55.2. Yes, 5.5. The decimal point must go here by 10 to the...
No, because you're giving the 10s to the 10.
Yeah, you're giving another 10 to the 10, yes. Yeah, this is should be the same number. So yeah, when we're... Yeah? Yeah, okay. All right, just be careful of those in standard form. If it's plus here, you can't use that. I would probably expand them both out for the easiest one. Some of you could do it without expanding, but if it's plus or minus, just write out the full thing. So this would be, if I want to change this, I would move the decimal point 6 spots. 2, 3, 4, 5, 6, which means fill in 5 zeros. So that's that number expanded out. Okay.
Can you multiply that or do add that? Like would I do that times 6?
When you do this?
Yeah.
I'm saying if there's a plus. If there was a plus, I can't use these indices rules. I can only use I have to do the slow way. So if this was a plus question, I gotta go, oh, well, I gotta do something slow. I gotta line up. I'd probably line up 2, 3, 4, 5, 6, 7, and then put these underneath each other so I have the zeros lined up, and then just add normally, and then put it back in standard form. Okay, order of operations, I presume you know, do brackets first, then exponents, all that. You would know that. They had maths, yeah. Rounding numbers, do be aware of the significant figures. If it's money, give it to 2 decimal places, because it's money, because money goes to 2 decimal places. Otherwise, round only at the very end of a question. And if you're unsure whether you should go 3 significant figures or not, give both answers. Like, let's say your answer is, it's an area and volume is usually a problem with this, 5, 6, 7, 3, 3, 0 or something, and you go, oh, that is it, and then maybe go rounded 3SF, and then you go, oh, well, was it 3, 6, 7, 0, 0, 0, and then so you just cover yours for decimal places, same thing.
But like, wouldn't they like only accept the one that you have on like the answer line?
Well, this the one I'd put on the answer line. Yeah, but just because it might come to a case where you're in the exam, you go, should I round this or should I not? And they will they'll be.
It's so dumb that they like don't tell you and then they'll subtract.
They'll say you'll read the front of the paper, and the paper will say round to 3 significant figures.
Oh. Okay.
Yeah, but just in case you're in the exam and you're not sure what to do. So, but only round at the very end. Keep as many especially for paper 4, keep as many decimal places as you can until the very end of the question. Then round. Otherwise, you'll be slightly off. You might be outside the bounds of a correct answer. Okay. Yeah, they might ask you to estimate in paper 2, using just approximation. So they might do, what is 4.97 multiplied by 8.21? Or something like that, and then divide by some, just round, yeah. So that's about 5 times about 8, and then that's 40, and that's what they're expecting you to do. Yeah, they're going to say estimate using rounding or something. It won't be as easy as that, maybe, but that's generally what they're looking for. Maybe you'll see those in past papers when you are doing them.
It says estimate, you can round it.
Yeah, they'll usually say how many decimal places to estimate to. We do, of course, know about time, so 60 minutes an hour, I presume you know. But proportion, we were a bit dodgy on, direct and inverse proportion. That might be something you all need to look at a little bit. Just make sure you read the question correctly. If it's inverse, direct is y is equal to k times x, and inverse is y is equal to k over x. Just remember that. And then inverse, usually it's with squared or square root or something. So just read it twice if it's square or square roots. A couple of people.
Oh, yeah, when they swap the x and y.
Y is equal to, you know when they say like y is equal to, I bet y is inversely to x, I bet it says like w is inversely direct to y.
Oh yeah, so it gives you a second one. So yeah, it works. So you got to work out the first one first, and then write.
And then put it in.
Yeah,
The same K.
yeah. It's not always the same K. No, not the same K. Don't listen to it. Yeah, the same value for y can go into the next one. Yeah. Maybe find an example like that and I can do it. I don't have one of those. Speed is distance over time, so you should be able to.
Are you sure?
I'm pretty sure speed is distance over time, and then work around distance is speed times time. Exchange rates can be a bit tricky. A good tip on exchange rates is make sure your answer makes sense. It's either going to be just dividing or multiplying by the exchange rate. If you're not sure what to do both, because it usually will be a calculator question. Do both and figure out which one it should be. You should know from the exchange rate which money should be have more than the other money. So it's just going to be dividing or multiplying by the exchange rate. That's a quick tip.
Centimeter squared to meter squared. You times by 100 and then by another 100, right?
Yes.
Okay, that's.
Yes. And if it's cubed, if it's a volume, then you have to do it 3 times. Okay, that's not in obviously unit 1. Sets. So some of the ones here that maybe this one, I think this is not this. That's a C with the, that's a subset. So what's a subset? Yeah, everything in one set is contained in another set. So if the elements of A is 1, 2, 3, and the elements of B are 1, 2, 3, 4, yes, then A is a subset of B.
Right, A is a subset of B.
That A is a subset of B.
Wait, what's the difference between, wait, I'm what's this?
Oh, union, yeah. It means more.
Union, intersect.
And then this one?
A, this, B is intersect. Where they cross over, what's in both?
This is where it intersects, and this is
Yeah.
all the other ones is all of them?
This is in both. And this is in A or B. It could be in A or B.
A and B, so it has to be intersected.
This has to be both, yeah, A and B, yeah.
But then
It's in A and B.
when it says like A, B, like, and then the
Complement, yeah, that's everything outside. So the complement is just the opposite.
Everything that isn't A or B.
everything that isn't A.
If I'm drawing A union B complement, that's everything outside here. That's A union B
Then
complement.
what if it's just A without the brackets and then it's B?
A without the brackets.
Like the same thing, but A, U, B.
Oh,
A, U, B dash.
A U B dash. Okay, so if you have something like this, I would. This board is.
A or not A.
If you're unsure on sets and shading, just I would draw them separately. First, I'll do a little sketch. Okay, here is my A and B. What's A? Okay, A is all this. All right, that's A. And what's the other one? Oh, B dash. Okay, so I'm going to draw everything out, shade everything outside of B, which is the other one. All right, and then I look at that. And then I go, all right, these two together means anything that's not shaded here, or this little bit, should also be included. Yeah?
Wait, so the,
I combine these two into one shaded diagram. Now, if it was intersect, that's different. That's where they cross over. Where they cross over. So now it's only this bit. If you see this bit, it's only this bit that's shaded in both diagrams. Has to be in both diagrams. Only this bit shaded in both diagrams. So that one would be this. So I draw them both separately if I'm stuck, because you can draw them in a second. And then look at, all right, everything that's shaded together, or if it has to be in both diagrams, this one in both, or just either or is the other one.
for A union B complement, would you include the intersection, yes? Or no?
Yeah.
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 Oh,
Yeah.
right.
A union with B complement. Anything in A and everything that's not in B together. Yeah. Okay, you practice those. Practice those. You're shaky.
Genuinely, like, look at his video.
Okay, so that's Venn diagrams, set identities. Okay, we know those. Okay, here are your questions. All right. These are the ones I think